LAC Flying School, our pre-flight briefing today on stalling. Our aim is to recognise and recover from a clean stall with minimum height loss. Why we need to cover this is to understand the mechanics of the stall, be able to practice it safely, and how to recover to safe flight if we are in a stalled condition. Our threat and error management. Our threats: other airplanes at all times, engine overheating, and terrain as we lose height. Our errors: stalling the airplane outside the flight envelope and loss of control. So how we're going to manage these is by keeping that lookout going at all times. Our Hazel checks, which is a new set of checks, and mass and balance calculation, especially important for the four-seat aircraft. Now the air exercise itself, initially a bit of revision, potentially on 30-degree angle of bank turns, picking up from your last lesson, just remembering that lookout attitude instrument work cycle. Then you might have already looked on the end of your last lesson, a demonstration of a clean stall. And I'd just like to point out that it's not violent or unpleasant, and that control is easily and safely regained. A lot of misnomers you might hear, but control is safely regained. Then we're going to split up the exercise into some different stages. We will do the entry, then we'll do the approaching stall, the lead up to the stall, and then the stall itself, then the recovery. So we'll start by having a look at the entry. We start by doing our Hazel checks. Now you'll find these in your checklist, and they will need to be learned and recalled from memory. They stand for height, airframe, security, engine, location. Location we then split down into A, B, C, C, D, which is active areas, built up areas, clouds, controlled airspace, and danger zones. So if you are in any doubts, do ask your instructor before you go flying if there's any questions about those checks. Better to clarify them on the ground before you get in the air. After that, the lookout. And we want to do either one 180-degree turn or two 90-degree turns. Always looking out before and during those turns. After that, we want to close the throttle and maintain balance using the rudder. Maintain level flight. Remember to progressively pitch the nose up to maintain level flight, progressively adjusting the attitude. Keeping the ailerons neutral, and then we can trim the aircraft down to about 60 knots. After 60 knots, we just want to be holding the forces on the elevator. Now shortly after welding these, we're going to start to see the lead up to the stall. And these are called the signs of the approaching stall. Whereby we've got low and decreasing airspeed, and it's going to be getting quieter as we're going to hear less wind noise outside. Controls are less responsive, a high nose attitude, stall warning, and light buffet. Buffet would be the airflow detaching away from the aircraft's surface, and it causes a slight shaking as you will feel in the air. Our main two would be the stall warning and light buffet. If for any reason that stall warning was inoperative or unserviceable, the light buffet would then be our key sign of the approaching stall. If we allowed the situation to develop and the stall to lead into the stall, we're going to start to see the symptoms of the full stall, and this is the stall itself, whereby we have stall warning continuously going off, heavy buffet now, a heavy shaking, high rate of descent, wing drop and nose drop. The wing drop and nose drop can be dependent on the aircraft you fly. After that, we'd potentially have a look at the power off recovery first. And I'd really like to emphasise at this point to do some studying to understand the mechanics and the principles of the stall. Stalling is just an angle of attack problem. We can stall the aircraft at any airspeed, and it's all about reducing the angle of attack, which is the angle between the airflow, relative airflow, and the wing. So again, stalling is an angle of attack problem. For the power off recovery, when we recognise a symptom of the full stall, control column centrally forwards until the buffet or stall warning stops. Holding the attitude then at that point, once the airspeed is increasing, level the wings, and then we can pitch for the glide. So again, if I just bring this model, control column centrally forward, that is the control column only going forward. We're not putting in any aileron input. So it's just control column centrally forward until the stall warning buffet stops. That is reducing the angle of attack and unstalling the wing. Holding the attitude, let the airspeed build, then at that point level the wings, and then pitch for the glide. From that, we will start to have a look at the standard stall recovery, which is at the first sign of the approaching stall, or depending on the exercise we're doing, the first symptom of the full stall, control column centrally forward until the stall warning buffet stops. Then hold that attitude. Simultaneously, we apply full power, preventing yaw with the rudder. Once the airspeed is increasing, level the wings, and then gently ease out of the descent. Caution that the aircraft may be in the yellow arc, the caution range for operating. Again, this is the standard stall recovery, and it's the same recovery we always do if we recognise the first sign or a symptom of a stall. From the standard stall recovery, we want to aim is to recover with minimum height loss. So if we can recognise the stall is coming, we can prevent it at that point. And that is called the incipient recovery. What we do is the standard stall recovery at the first sign of the approaching stall. The first sign, remembering, stall warning, or if it's an operative, like buffet, these are the main key signs, the others may be less apparent. As soon as you recognise the sign of the approaching stall, you do the standard stall recovery. Now, one last thing I want to mention. We said in the symptom of a full stall might be a wing drop depending on the aircraft. There's a lot of misnomers you can hear about what to do with a wing drop. Your main aim is to reduce the angle of attack. So whenever the aircraft's in a stall condition, we don't want any aileron input. The effects of the aileron at the stall are unpredictable, and coarse use may produce undemanded roll, potentially in the opposite sense. So these are unpredictable. At the stall, we don't want any aileron input. We just want control column centrally forward to reduce the angle of attack. Only once the airspeed is increasing, then level the wings. And that is the end of our stalling briefing. Thank you for watching. Goodbye.